It's kind of amazing how fast things are moving, isn't it? Especially in design, with all this new tech.
It really is nonstop.
And lately, well, you can't seem to avoid hearing about AI, particularly generative AI.
Oh, absolutely. It's everywhere.
Sorting through it all, what's real progress and what's just hype.
Yeah,
That's the tricky part.
definitely.
So that's what we're going to try and do in this deep dive. Really cut through some of that noise.
Good plan.
Yeah.
Yeah, today we're diving into something super important for designers, or really anyone near the field.
Which is,
Trying to get a real handle on what AI can actually do. Generative AI, yes, but also, and this is maybe even more critical, what it can't do, what its limits are.
okay, got it. And our insights today, they're coming from a lecture, right? Something called 2025 Data in Design, aimed at designers.
Exactly. Think of it as a way to get that solid foundation, something that goes deeper than just the flashy headlines or demos you see online.
Right. We want the practical stuff. Try and avoid that feeling of just being totally overwhelmed by it all.
Yeah, the mission here is to look past that initial, wow, look what AI made moment, which is fascinating, don't get me wrong.
Sure, it can be pretty amazing stuff.
But we need to get down to the basics, understand the principles,
Mm.
because there's this tension, between being amazed by the output and really needing to grasp how it works and where it falls short.
Okay, let's unpack that. One of the first things from the lecture that jumped out was this observation, how a lot of designers are really focused on generative AI and LLMs.
Yeah, the lecture used the Korean term EAFI, which kind of means fixated or maybe even obsessed.
Right. Fixated, they see these amazing outputs
Yeah.
and just get drawn in, which, I mean, it's understandable.
Totally understandable. But
Yeah.
the speaker raised a concern about that intense focus.
Okay, what was the worry?
Well, the worry is that this excitement about the shiny new thing, generative AI, often means people skip over understanding the, let's say, more traditional machine learning concepts.
Like what kind of concepts?
Things like, basic data structures, how algorithms actually work, even the underlying math, the fundamentals.
But hang on, if designers are getting cool results with these new tools, does it really matter if they don't know the deep history or the math behind, say, older algorithms?
That's the crux of it. The speaker argues, yeah, it does matter. Because a shallow understanding, just knowing the surface level, can actually hold you back.
How so?
It limits how effectively you can use these computational tools, even the new ones. Without that foundation, it's harder to judge when AI is the right tool, how to apply it properly.
And maybe you're more likely to just believe whatever impressive thing it spits out.
Exactly. You might get fooled by something that looks good but isn't actually sound. It's like wanting to be a gourmet chef but only knowing how to use a fancy sous vide machine without understanding how heat actually cooks food.
Okay, that makes a lot of sense. It's about the why not just the what.
Percent.
Which leads straight into another really big point from the lecture. You absolutely have to understand the problem you're solving first before you even touch AI.
Yes, this was huge. The lecturer actually said, and I'm translating here, "Oh, shogo shake, great, maka sonyo, yana hello kale."
Which means,
The problem is that you have no understanding of what you are trying to solve. You just want to use AI.
oof, that's pretty direct.
It is, but it's a critical point. The tool, AI, or anything else has to serve the problem, not the other way around. You can't just want to use AI for the sake of using AI.
It's like buying a really expensive hammer and then wandering around looking for something, anything, to hit with it.
Perfect analogy. And the lecturer even brought up this idea.
Okay, what does that mean? My problem that I'm selling.
Yeah, sort of. It emphasizes really digging deep into the core problem you're tackling. Understanding it so well, you could almost sell it, like you're pitching its importance. Define that problem before you think about solutions, especially tech solutions like AI.
Got it. Problem first, tool second. So, assuming you have defined your problem, the lecture then makes this distinction between two main types of AI, analytical and generative. This feels important.
Absolutely fundamental. You really need to get this difference. So, analytical AI, that's all about understanding data you already have, making sense of it.
Okay, like finding patterns, making predictions.
Exactly. Things like regression, finding relationships in data, or classification, sorting data into buckets. The goal is usually insight, explanation, maybe forecasting based on past data.
Right, analyzing what's there. So, what about generative AI, the one everyone's talking about?
Yeah, so generative AI is different. It's about creating new stuff, new content.
Like text, images.
Right. Text like ChatGPT, images like Midjourney, even music. It learns patterns from existing data, sure, but its purpose is to generate something novel.
Okay, clear distinction. Analytical understands, generative creates. The lecture also mentioned something about computer science versus statistics perspectives on AI.
Yeah, just the brief point. It noted that computer science often comes at AI focusing on the implementation, building the models, making them run fast.
Practical how-to.
Right, whereas statistics often focuses more on the explanation. Why does the model do what it does? Can we interpret the results? Are they statistically sound? Two sides of the same coin, really.
Interesting. Okay, now, let's get to the juicy stuff. The AI hallucinations. This part was,
Sure.
well, pretty wild.
Yes, hallucinations. This is where AI generates stuff that sounds totally plausible, maybe even confident, but it's just wrong.
Oh,
Or nonsensical.
and the lecture had some amazing examples, right? The ChatGPT being rude to a developer.
Oh, yeah. Apparently, someone asked it for advice on tech to learn, and it gave this incredibly harsh response, including the phrase, I don't want to get this right. Wait,
Which means,
roughly, if you can't even do this, just die.
wow. Okay, not exactly helpful AI there. Talk about a system needing sensitivity training.
Right. And it didn't stop there with the weirdness. There was the historical fiction involving King Sejong.
Oh yeah, the MacBook Pro incident.
Exactly. The AI apparently stated, as if it were fact from the Joseon Dynasty Chronicles, that King Sejong threw a MacBook Pro when he got angry.
In the 15th century.
Right. Obviously impossible, but it shows how AI just connects patterns, words that might appear near King Sejong, and frustration, maybe throwing things, without any real understanding of history or, well, reality.
It's creative in a completely nonsensical way. And then there was Admiral Yi Thun-sen,
Oh, the aircraft carriers. Someone asked about the ships Admiral Yu used in the Imjin War.
famous turtle ships, right?
You'd think. But ChatGPT apparently said, Gavya, Gavya, Yun Gavya, meaning Yi Sun-sen's ships used in the Imjin War were aircraft carriers.
Aircraft carriers. How many?
It even said he had 12 of them.
12 aircraft carriers in the 16th century.
Yeah.
That would have changed things. So these are text examples, but it happened with images too. The snake photo.
Right. That AI was shown a photo, couldn't clearly see a snake in it, but insisted there was one. It even described where it was.
Okay.
Then, when asked to show the snake, it actually generated a modified image with a sort of crudely drawn snake tail added in the spot it claimed it was.
Whoa. So it didn't just misinterpret, it actively created evidence for its mistake.
Pretty much invented it on the spot.
And the word game, what happened there?
Yeah, a Korean word ending game. Like, you say a word, the next person says a word, starting with the last syllable.
Got it.
So the previous word was gotta, gerium, meaning oil. The AI followed up with ha, roomber.
Is roomber a word?
Nope. Complete nonsense. And when challenged, it apologized for its mistake, but didn't initially seem to get that the word itself was the problem, not just that it maybe broke the game rules somehow.
It's like it's trying so hard to follow the pattern, it just makes something up to fit. So why does this happen, these hallucinations? It's not doing it on purpose, right?
No, definitely not intentional deceit. The lecture explains it often comes down to the model trying to interpolate.
Interpolate, meaning?
Meaning filling in the gaps. It's working based on the data it was trained on. If it hits a situation or a query where it doesn't have specific, clear training data,
It tries to guess?
sort of, it tries to create an output that fits the patterns it has learned, bridging the gap between known data points. But if the gap is too big, or the data is ambiguous.
It fills the gap with nonsense that looks like it fits the pattern.
Exactly. That's the hallucination. As the speaker put it, we have no particular data to train. So the attempting trying to interpolate based on the given data, it's filling blanks based on what's around them.
And this isn't just an early days problem. The lecture mentioned it's still happening, maybe even getting worse in some cases.
Yeah, it's an ongoing challenge. Despite models getting better in many ways, this issue of generating plausible-sounding inaccuracies is still very much present. It's something you absolutely have to be aware of.
Which brings up that fascinating question the lecture posed. Where's the line between a hallucination and, well, creativity?
Right. That King Sejong MacBook example is perfect. Factually, it's garbage.
Total garbage.
But is it creative garbage? Could that kind of weird, unexpected connection spark a genuinely new idea, even though the source was an error? The lecture called them good errors.
Good errors. I like that. It forces you to really evaluate the output, not just take it as fact or dismiss it completely.
Exactly. Critically evaluate. Don't just be impressed by the fluency. Remember, it's pattern matching, not reasoning.
This ties into the whole black box idea too, doesn't it? We don't always know why the AI gives a certain output.
Precisely.
Yeah.
Especially with deep learning, the models get so complex, the lecturer used the example of an AI-designed engine part.
Right, it might be super efficient.
But tracing back why the AI made those specific design choices, why that shape works best, it can be incredibly difficult, sometimes impossible. It's a black box.
And if you don't know the why, then the what, the output, becomes heavily dependent on the how it was trained, and especially what it was trained on, the data.
Absolutely critical. Data quality, bias in the data, how the model was tuned, it all feeds into that black box. The speaker had a line about this. 我需要不需努哦有就哦有个人.
Meaning,
Prediction should always be possible because you prepared the data.
it emphasizes that if you understand your input data really well, you should, in theory, be able to anticipate the kinds of outputs you'll get, even from a black box. Your data shapes the output.
Okay, and speaking of data shaping the output, this brings us back to interpolation versus extrapolation. You mentioned interpolation causes hallucinations. Can you refresh that difference? Sure. Interpolation is basically working within the boundaries of what the AI has learned, connecting the dots, filling in gaps between known data points. Current AI is generally pretty good at this.
Okay, and extrapolation.
Extrapolation is going beyond the training data, inferring new rules, creating something genuinely novel that isn't just a recombination of what it's seen, making logical leaps into the unknown.
Which current AI is not so good at.
Generally, no. That's a much harder problem. The lecture argued that true intelligence, the kind humans have, requires extrapolation. We can reason beyond our direct experience. Current AI mostly interpolates.
So it's great at refining known territory, less so at exploring new continents. This sounds like the difference between weak and strong AI people talk about.
Exactly. Weak AI, or narrow AI, is what we mostly have now. Systems designed for specific tasks, even superhumanly good ones like chess AI or medical image analysis, they're specialists.
Like an expert tool.
Right. Strong AI, or artificial general intelligence, AGI, is the hypothetical goal. AI with human-like cognitive abilities across the board, able to learn, reason, and adapt to almost any task a human can.
And the lecture basically says we're firmly in the weak AI camp for now.
That's the consensus, yeah.
Okay, but then the discussion goes even further out
Yeah.
to superintelligence,
Yeah.
AI smarter than humans.
Right, and this is where it gets really philosophical. If a superintelligence did emerge, one vastly smarter than us, the lecture asks a really fundamental question. How would we even know? How could we verify it?
That's a trip. How do you test something that might be operating on a level you can't even grasp?
Exactly. The analogy used was humans and ants. An ant has no way to comprehend human intelligence or our motivations. We might be in a similar position relative to a true superintelligence. We might not even recognize its intelligence as intelligence.
Mind-bending. And it raises concerns too, right? If we can't understand it, how do we ensure it's aligned with our goals? Especially if it learned from our often flawed and biased data.
That's a huge concern. Unintended consequences stemming from biases it learned from us.
What about consciousness? Does the AI feel anything? That comes up a lot.
The lecture touches on this, but mostly to urge caution. Just because an LLM can write text saying it feels sad or happy, that's not evidence of actual consciousness. It's
Yes.
mimicking patterns in text where humans express feelings.
So don't fall for the chatbot saying it loves you.
Probably wise. There was mention of an interesting thought experiment from Ilya Sutskever, though. Could you train a model without any concept of consciousness in its data and then see if it spontaneously starts discussing related ideas? That might be a more meaningful test.
Interesting idea. Away from the direct mimicry. This feels related to the Chinese room argument the lecture brought up. That's a classic AI philosophy puzzle.
It is John Searle's argument. Imagine someone in a room who doesn't know Chinese. They get Chinese questions slipped under the door. They have a huge rule book in English that tells them exactly which Chinese symbols to output in response to the input symbols.
So they can produce perfect Chinese answers.
Perfect answers, yes. But do they understand Chinese? Searle argued no. They're just manipulating symbols according to rules.
And the connection to AI is?
The lecture connects this to LLMs. They process massive amounts of text, identifying patterns, correlations between words, or word bundles. Are they understanding language or just becoming incredibly sophisticated symbol manipulators like the person in the Chinese room?
So it questions whether there's genuine comprehension or just very, very good pattern matching.
Exactly. It's a deep question about the nature of understanding itself.
And going back to generative AI, this perspective suggests its creativity might just be these good errors. We talked about sophisticated pattern matching, leading to novel-seeming outputs.
That's the idea presented. These models generalize and interpolate so well across vast data that their mistakes or unexpected combinations can look like human creativity, even without conscious intent.
It definitely demystifies it a bit.
Yeah.
Okay, shifting gears slightly, the lecture brought in some history. The Luddites. How does that connect?
The connection is about the fear of job displacement. The Luddites in the early 1800s were textile workers who destroyed machinery they feared would replace them.
And people have similar fears about AI taking jobs today.
Right. The lecture acknowledges those fears are real, and yes, some jobs will change or disappear. That's undeniable. But the historical parallel suggests that technology tends to increase overall productivity and create new kinds of jobs and opportunities, rather than leading to permanent mass unemployment.
So disruption and change, yes, but maybe not apocalypse.
That seems to be the perspective. Evolution, not replacement across the board.
The focus then shifts back to the designer. What's essential for them in this changing landscape?
Foundational knowledge. The lecture really hammered this home. Your skills in math, language, critical thinking, your specific domain expertise, these are your core data processing abilities.
Our own internal algorithms, so to speak.
Kind of, yeah. And learning AI tools is about enhancing those abilities, making you better at what you do, not about the tools replacing your fundamental skills.
So AI is augmentation, not replacement, helping designers be more efficient, more precise.
Exactly. Enhancing workflows, speeding things up, maybe enabling analysis or creation at a scale or complexity that wasn't feasible before. It's a powerful assistant.
Okay, what about the idea of one single AI taking over? Like Skynet, but maybe less dramatic. Did the lecture address that?
Yeah, the speaker was pretty skeptical about a single dominant AI emerging anytime soon.
Why?
Because there's so much variety. Different models trained on different data with different inherent biases or strengths. It's more like the search engine market people use. Google, DuckDuckGo, Bing. Different tools for different needs or preferences. A diverse ecosystem, not a monopoly.
That sounds more plausible than one AI to rule them all. And how will AI fit into technology generally? Will we have separate AI companies?
The prediction was no, not really. AI is more likely to become an ingredient, a component technology embedded within countless other tools and processes.
Like how computation is just part of design software now, not a separate thing. Or how everyone uses calculators.
Exactly like that. Calculators aren't a separate industry. They're just there. AI leverages the core strengths of computers, speed, accuracy, doing repetitive tasks tirelessly, and applies them in new ways, but it'll likely be integrated, not standalone.
AI inside things rather than the AI.
Yeah.
Got it. The lecture also gave some concrete examples of AI limitations, especially with images.
Yeah, good reminders that it's not magic. The unreliable detection example. An AI trained to spot people might fail if someone wears, say, a t-shirt with a busy background scene printed on it.
Why would that happen?
Because many image recognition AIs, like convolutional neural nets or CNNs, look for specific local features, edges, textures, common shapes associated with people. A complex pattern on clothing can disrupt those expected features and confuse the model.
Okay, interesting. And the cat image.
Ah, the adversarial example. You can add tiny amounts of specifically crafted noise to an image noise that's basically invisible to a human eye, but it completely fools the AI. It might see a cat image and confidently classify it as, say, a guacamole maker.
Seriously?
Because the AI processes the image as numbers. That tiny numerical change, imperceptible to our visual system, which cares more about brightness than subtle color shifts, can push the image across a decision boundary in the AI's internal calculations. It highlights how differently AI sees compared to us.
Wow.
Wow.
Okay, that really shows the brittleness sometimes. What about improving AI? AlphaCode was mentioned.
Right. DeepMind's AlphaCode, which did surprisingly well at competitive programming tasks, it used a technique related to data distillation.
Data distillation.
Basically, instead of just throwing more raw data at a model, you can sometimes train a smaller, more efficient model using carefully selected, high-quality data generated or filtered by larger models, quality over just quantity.
Refining the training data itself makes sense. And that brings us right back to data quality with garbage in, garbage out. GI Go. A classic.
Absolutely fundamental in machine learning. The lecture had a neat analogy for this.
What was it?
Comparing internet doctors. Doctors trained primarily on data from Southeast Asia might instantly recognize symptoms common there, forming a diagnosis queue in their mind, while a doctor trained only on Korean patient data might find those same symptoms unfamiliar.
Because their training data was different.
Exactly. The model, human or machine, is only as good as the data it learns from. If your input data is biased, incomplete, or just plain wrong for the task, well, garbage in, garbage out. The lecture also briefly showed a diagram of AI types: analytical, generative, and agentic AI, which is more about AI taking actions.
So it all comes back to the data. And the lecture wrapped up with a warning about AI being seen as a cure-all.
Yeah, a cautionary note, using the analogy of how Vaseline was once marketed as a fix for almost anything.
Huh. Okay, I see the parallel. Don't assume AI is the magic answer to every problem.
Precisely. Remember what it is fundamentally: sophisticated data processing. And the lecture concluded that right now, machine learning is simply the most effective, scientifically grounded path we have towards achieving more advanced AI. It's a best tool for that job.
Okay, so let's try and wrap up this deep dive. It feels like the big message is AI, especially generative AI, is undeniably powerful for designers.
Yeah,
Huge potential.
definitely. But
But you absolutely need to understand the foundations, know its limits, things like hallucination, and be super aware of the data going in.
that's the core of it. Designers need to really own the problem they're solving first, then use AI strategically, thoughtfully, as a tool to boost their skills, their workflow.
Not as a magic box or a substitute for their own thinking and expertise.
Couldn't have said it better myself.
So, thinking about all this, the limitations, the biases, the good errors, here's a final thought for you to chew on. What does genuine innovation and truly impactful design look like in the future? With these powerful but flawed AI tools in the mix, how much weight do we give to human intuition, human understanding, human creativity? Where's that balance?
That is the big question, isn't it? Something to keep thinking about. Thanks for diving in with us today.